Hey everyone, in this video we are going to solve the equation x minus 2 times x minus 3 times x minus 4 times x minus 5 is equal to 840, i.e. we are going to find all x such that our equation holds. Let's begin by multiplying x minus 2 by x minus 3 and x minus 4 by x minus 5. X minus 2 times x minus 3 gives x squared minus 5x plus 6, and x minus 4 times x minus 5 gives x squared minus 9x plus 20, and remember, this all equals 840. Now let's multiply these two quadratics together using the method of detached coefficients. We begin by multiplying 20 by each number in the first row. This gives us 120 minus 120. We then move to the number on the left of 20, which is 9, and begin multiplying it by each number in the first row, making sure to write our first result in the same column as 9, and finally moving on to 1 and doing the same. At this point we add the numbers within the same columns together. Our first column consists only of 120, so we just have 120. Moving on to the second column, we have minus 100 minus 54, which equals minus 154, so we write minus 154. Continuing in this way, we get the coefficients of our polynomial produced from multiplying our two quadratics above. All we need to do is subtract 840 from both sides of our equation. Doing so, we get x to the fourth power minus 14x cubed plus 71x squared minus 154x minus 720 equals 0. So the solution to our original problem basically boils down to finding the roots of our quartic equation on the screen. We could do this using Descartes' method or some other root finding algorithm, but when dealing with polynomial equations of high degree, I think it can be useful to try and guess the solutions, because if you know a solution, you know a factor of your polynomial, and you can then rewrite your original polynomial as a polynomial 1 degree lower multiplied by that factor, and then use polynomial long division to figure out the polynomial that is 1 degree lower. Good numbers to try would be the integers from 1 to 10 and their negative counterparts. If you were to do this for our specific problem, you would see that x plus 2 and x minus 9 are factors of our quartic equation. So we can rewrite our quartic equation as x plus 2 multiplied by x minus 9 times q of x, where q of x is a quadratic equation yet to be determined. If we multiply x plus 2 and x minus 9 and divide by the result, we get the following rational equation for q of x. Now we can solve this rational equation using polynomial long division. I won't go into the details about how to carry out the polynomial long division, but if you have any questions, let me know in the comment section below. First we divide x to the fourth power by x squared and write the result above. Then we multiply x squared by our quadratic and then subtract the result from our quartic. So x squared times x squared is equal to x to the fourth power. Subtracting it, we have minus x to the fourth power. X squared times minus 7x is equal to minus 7x cubed. Subtracting it, we have 7x cubed. X squared times minus 18 is equal to minus 18x squared. Subtracting it, we have 18x squared. Now, x to the fourth power minus x to the fourth power is equal to 0. Minus 14x cubed plus 7x cubed is equal to minus 7x cubed. And 71x squared plus 18x squared is equal to 89x squared. Repeating this process, we divide minus 7x cubed by x squared, producing minus 7x. And then we multiply everything in the quadratic to produce the fourth row, just in the same way we produced the third row. We continue in this way until we get to 0, and through this process, we have found our quadratic q of x to be equal to x squared minus 7x plus 40, which we can solve using the quadratic formula. Now, we have the square root of minus 111. We can rewrite this as the square root of minus 1 times the square root of 111. And remember, the square root of minus 1 is equal to I, so the square root of minus 111 is equal to I times the square root of 111. Therefore, the solutions to our equation are x is equal to minus 2, 9, 7 plus or minus I times the square root of 111 divided by 2. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe? If you have any questions or problems you'd like to see get solved in future videos, let me know in the comment section below. I hope you have a great day.